This is 1.3 Evaluating Limits Analytically, Day 2. So yesterday we talked about a bunch of our basic rules for finding limits. We're going to continue with that. So the first thing we're going to talk about is limits of trig functions. If you remember, with polynomials and rational functions, we were able to just plug in that c value. The same thing applies for trig functions. So if we look here, the limit as x approaches 0 of tangent of x. Well, let's just plug in our c values. So we get tangent of 0. And tangent, remember, is sine over cosine. Sine of 0 is 0 over 1, which gives us 0. Same thing for the next one, the limit as x approaches pi of x cosine of x. So let's just plug in pi wherever we see an x. That gives us pi times cosine of pi. And we know that cosine of pi is -1. So pi times -1 is just negative pi. And then you're done. So trig functions, pretty easy. Now, yesterday we talked about rational functions and how we can just plug in as long as the bottom doesn't work, or the bottom isn't 0. So now we're going to talk about what if that bottom becomes 0. All right, so we are going to notice that in this one, the limit as x approaches 1 of x cubed minus 1 over x minus 1. Notice that if we directly substitute in a 1, 1 minus 1 gives us 0 on the bottom, and that doesn't work. So what we can do is we can factor and see if something's going to cancel out. So let's look and try this one here. So if we factor x cubed minus 1, if we factor the top, we get x minus 1 times x squared plus x plus 1 all over x minus 1. Reminder, we're still taking that limit as x approaches 1. Notice this x minus 1 cancels with the next x minus 1, which allows us to do that direct substitution. We can just plug in that 1 here to this, and 1 squared is 1. 1 plus 1 plus 1 is 3. So our limit is 3. You may also get something that looks like this. So the limit as x approaches 0 of the square root of x plus 1 minus 1 all over x. Notice that factoring isn't going to work here. If factoring doesn't work and you have this radical in either the top or the bottom, you need to multiply both the top and the bottom by the conjugate. So remember, the conjugate of the square root of x plus 1 minus 1 is the square root of x plus 1 plus 1. Square root of x plus 1 over the square root of x plus 1 plus 1. Remember, just like fractions, the second piece here is equal to 1, so we're not changing the value, we're just making it look different. Go ahead and multiply out, and then you should be able to do direct substitution to get to your answer. Last but not least, we have some special trig limits. So we talked about this one with graphing. The limit as x approaches 0 sine of x over x. If you look at the graph of that, it has a hole at x equals 0. We found out using a table and the graph that that limit is 1. So that's one special trig limit you might want to remember. Another one is the limit as x approaches 0 of 1 minus cosine of x all over x. That limit is 0. You can verify that using a graph if you want. So the limit of x approaches as x approaches 0 of tangent of x over x. With this one, it's not one of our special trig limits, and if we do direct substitution, it fails because the denominator goes to 0. What we want to do is we want to see if we can make it look like one of those special trig limits. So remember, tangent of x is like sine of x over cosine of x. And then dividing by x is like multiplying by 1 over x. Still taking that limit. And I'm going to rewrite this to be the limit as x approaches 0 of sine of x over x times 1 over cosine of x. This works really well because we know that the limit of as x approaches 0 of sine of x over x is 1. So we have 1 times, we can do direct substitution for that second part, cosine of x, or cosine of 0 is 1. 1 over 1 is 1. So we get 1 times 1, which is just 1. If you ever have questions, go ahead and verify it using your graphing calculator. You can also use a table. But otherwise,